All right, 23. So we got this 5 kilogram bucket of water. It's being raised from a well by a rope. What do we call force in a rope? Tension. Is there a normal force on this bucket? No, it's not on a surface. If it's being raised from a well, there's no normal force. We're told the upward acceleration of the bucket is 3 meters per second squared. Find the force exerted by the rope on the bucket. So what are they asking for here? Find the force exerted by the rope on the bucket. What is that? The tension. They want us to solve for the tension in the rope. Okay, so we always start with a free body diagram for problems like this. So here's the bucket. There's the bucket. What are the forces on the bucket? Gravity down. So force of gravity is also called weight. The equation is mg, so I label that mg. The upward force acting on the bucket is the tension in the rope. Okay, any other forces? Nope, that's it. Okay, sign convention, up is plus, down is minus. That's going to, unless otherwise stated, that's our sign convention. So now, thanks. So now we sum the forces. What is the sum of the forces always equal to? Ma. But let's sum them first. Let's sum the forces. Okay, so what are the forces on the bucket? Well, we have T up, so that's positive, and then mg down, so that's negative. So T minus mg. That's the sum of the forces. So what is the sum of the forces equal to? Ma. So this is the equation that solves the problem. Chapter 4, for the most part, it's like a write your own equation chapter, And one problem is going to be different than the next problem, So don't memorize solutions. That you definitely don't want to. This is not biology. You're not going to make your way through physics by memorizing solutions. You got to understand how you're doing them. Okay, so they tell us the acceleration of the bucket. Which way is the acceleration? Up or down? Up. So put a little arrow here. The acceleration is up, and that's positive 3. Positive for up. All right, so now we solve this for T. So T is going to be equal to Ma plus mg. So you can factor the m out just to make it shorter. A plus g. All right, so this is going to be, so m is 5 kilograms, and then a is 3. The given acceleration is 3, and then gravity. In the textbook, you guys use 9.8. In class, I use 10 a lot, but this is a textbook problem, so we'll use 9.8. Now, guys, isn't gravity negative? See right here? Did I plug in 9.8 or negative 9.8? I plugged in. This is right here. This is a point of confusion for a lot of students. Kids will say, like, Spaldo, I thought you said gravity is negative. And I'm like, it is negative. But look, right here. What did we call mg up here? Did we call it plus mg or minus mg? Minus mg. So we've already put gravity as being down into the problem. A general rule, once you've summed the forces, you're done with sign conventions. We've already, right in here, we've dealt with the sign conventions. Plus, minus. So don't put in another minus down here, because then you've called gravity minus twice, which is the same as calling it plus. Does that make sense? Okay, so then tension comes out. So that's going to be 5. So the tension in the rope is 64 newtons. 64 newtons. Okay. Hey, just the question doesn't ask for this, but what's the net force on the bucket? What's the net force? This is the tension, right? We figured out that tension is 64. Tension is 64. Okay. Mg is what? 5 times 9.8. 5 times 9.8. That's 49. What is the net force on this bucket? 15 newtons. F net. And how did I get that? Well, 64 up, 49 down. That's 15. Or what's another way you could have found net force? You could have gone, oh, net force equals ma. The mass of the bucket's 5. The acceleration's 3. Aha, what's 5 times 3? 15, right? Yo.
Why aren't we writing gravity as negative?
Why are we?
Yeah, why aren't we writing as like a negative acceleration?
Oh, that's what I was saying. Are you talking about like right here?
Yeah.
Okay, so what I was saying is gravity is negative, but we already called it negative up here. We already noted that gravity is negative. Yo.
For the test, you want to shoot 9.8 or 10?
You know what? I'm going to write the test probably the day before. So I don't know. I'll tell you on the day of the test. You know. But look, the answers on the test, I'm not going to have the answer choices aren't going to be like 15, 15.1, 15.11, you know. The answer choices, this isn't chemistry, you know. In chemistry, sig figs are a real big deal. In physics, you know, the answer choices will be far enough apart where 10 and 9.8 won't matter. But I'll tell you on the test. On the AP exam, they want you to use 10. On the College Board test and the SAT 2, 10. They're just doing you a favor, because would you rather go like m times 10 or m times 9.8? 10. Multiplying by 10 is easy.
Do you get a calculator?
You on the AP?
Or, yeah, when you have to use 10.
On the AP test, no calculator on the multiple choice. On the free response, you get a calculator.